Now we will learn about the graph of logarithm, or simply logarithmic graph. Y equal to ln x, it looks like this. It starts from negative infinity, crosses x-axis at the point 1 and it increases. When we will draw y equal to ln minus x, this curve will flip this way. This side will come to this side. See here, simply this. When we will draw y equal to minus ln x, this will flip like this. This upper portion will come in the lower portion and this lower portion will come in upper portion. And y equal to minus ln minus x, you can simply see here that this has been flipped in this way. This upper portion came in the lower portion. The task I will give you is to draw this shape at least 2 times so that you can memorize these shapes, the shape of ln x, ln minus x, minus ln x and minus ln minus x. You can see here the graph of ln x. Now, if I ask you to draw the graph of y equal to ln x plus 1, how can you draw this? When a constant will be added to a logarithmic function, the graph will rise upward. So this time the graph will look like this. This point is 1. And if I ask you to draw the graph of y equal to ln x minus 1, the graph will go downward 1 unit. This time the graph will look like this. And what will happen if I would have written here y equal to ln x minus 2, then this line will become y equal to minus 2. And if I would have written here y equal to ln x plus 3, then this line would have been become y equal to 3. This is the scenario. How the graph of ln x changes with something being added with y. Now we will see the x-axis shifting. Here I have shown the y-axis shifting. A value is being added to the whole function. When we have added a 3 with the whole function, the whole graph has been raised 3 units. When a 2 is subtracted from the whole function, the whole graph descends 2 units. This is the case when a constant is being added with the whole function. And what will happen if I add or subtract a constant from only the x portion? For example, if I say that draw the graph of y equal to ln x minus 2, when you see something is being subtracted from x, the whole graph will shift right side. Here you can see x minus 2. That means this graph will shift 2 units right. This is the graph of y equal to ln x minus 2. Now, if I ask you to draw y equal to ln x plus 2, what will happen? This curve will move leftward by 2 units. That means this will move 2 units left. This time the curve will look like this. This has been moved 2 units left and now it looks like this. For example, this one has been moved to this point minus 1. This point, this straight line has been moved to 2 unit left at minus 2. You can see that this line has been moved here. This point has been moved here, and here the whole curve moved 2 units right. So 1 came to the point 3 and this line moved 2 unit and came at the point 2. These are shifting in x-axis and these are shifting in y-axis. When you will see any plus, that means it will move upward. When something is being added with the whole function, the function will move upward. When something is subtracted from the whole function, then the whole function will move downward. When something is being subtracted from only the x, not the whole function, only the x, then it will move to right. And when something is being added with x, then the function will move left. You must memorize these 4 conditions: when to go right, when to go left, when to go up, and when to go down. And you need to practice these shapes. Now, while you are watching this video, I am commanding you to practice these figures at least 2 times. Now we will learn 4 more changes. For example, now we will learn y equal to 2 ln x. What is the impact of these 2 here? When something is being multiplied with the whole function, then the function will be spread in y-axis. It will look like this time like this. This will spread in y-axis. If we write ln x divided by 2, when we will divide the whole function by any constant, the function will squeeze along y-axis. This will look like this. This is the impact of something being multiplied or something being divided from the whole fraction. Now we will see what is the impact when something is being multiplied with the x only. When x is multiplied with any integers, the whole fraction will squeeze. This point 1 will come to the point half, and this shape will become this shape. The whole graph will squeeze when something is being multiplied with x. And what happens when the scenario is exactly opposite? When we will write y equal to ln x by 2, this time the graph will expand. This point 1 will be multiplied by 2 and this will come here. So the graph will look like this time when we will write x by 2. So I am writing this. When x is divided by some integers, graph will spread 2 times along x-axis, or simply we call it will spread 2 times sidewise. If I would have been written x by 3, then it would have been spread 3 times. For example, if I would have been written here x by 3, it would have expanded 3 times and it will look like this. This graph has been spread 3 times sidewise. When something is being multiplied with x, the whole graph will squeeze. How much will it squeeze? It will depend on this. If 2 is multiplied with x, it will squeeze 2 times. When something is being multiplied with the whole function, the graph will spread. In which direction? Vertically. This will spread this way. You can see here that. Here it is multiplied by 2, so it will spread 2 times vertically. And when the whole function is divided by something, the whole graph will squeeze vertically. You can see here that this shape has become halved. These are the scenarios how multiplication with the whole function and multiplication with x modify the shape of a logarithmic curve. And you know that the graph of y equal to ln x and y equal to log x is same. And what to do now? Practice these shapes at least 2 times.